What's up, everybody? This is 413, and in this video, we are continuing to build towards a proof of something called the trapezoid midsegment theorem. Now, we're going to need to use the diagram on the bottom of page 412. It kind of set up the work for this one. So if you haven't done that video, done those notes yet, why are you skipping forward? Go back and do 412. Make sure that that video, you've gotten all the way down to the information at the bottom. Have a highlighter ready to go, and you'll see I've kind of prepped the page by answering most of the questions. But at any point along the way, you can skip forward or pause and write down, and then come back and just kind of figure out what's being said. Let's take a look at that diagram, though, on page 412, as we're going to use that diagram to set up what we need to be successful in this video. A couple of things that you need to notice: that the line ME is extended to create the line ET, and that creation actually ends up creating equal segments. So I'll try to highlight them here a certain color. I'll highlight that ME and ET actually are the same length. Because of alternate interior angles, which is something we're going to see, you're going to write that down in a minute. This angle and this angle are the same, and you'll see it also written up too. Just kind of highlight it when it gets there. When two lines cross, they create vertical angles, and because they create vertical angles, that means that those angles are congruent. So there's actually a pair of congruent triangles inside this diagram, namely the triangle GME and the triangle STE. Those two triangles are congruent, and because they're congruent, corresponding parts of congruent triangles are congruent, and that's going to allow us to really, I guess, prove what is the actual statement for trapezoid midsegment theorem. This line right here, that is the midsegment, is half of the measure of both of those two things, and it's also parallel to the bottom as it is also parallel to the top. So arrows and arrows on all three of those horizontal lines. Let's talk about it. Let's go back over here, page 413. Is that angle MGE congruent to the angle TSE? Yes, because I know that because it's a trapezoid, that the two bases, MG and D, well, it's DS, but they've extended DS out to DT, that those two lines are parallel. It's a trapezoid. You got to have parallel lines. Now, when those parallel lines are cut by a transversal, and the transversal in this case is GS, yeah, GS, that's the one. GS is the transversal we're talking about. It creates alternate interior angles. And so those alternate interior angles are allowing us to acknowledge that MGE is congruent to TSE. I think, I'm going to go back to my diagram. I didn't sketch that in. This is the pair of angles they're saying are in common. Okay. We've established congruent angles. What else can we establish? Is triangle MGE congruent to triangle TSE? And yes, it is. Yes, again. And the reason is because of angle, side, angle, triangle congruence. The thing is, angle GEM and angle TES, those are the vertical angles that I mentioned just like 30 seconds ago. They are congruent because they're vertical angles. Also, E is the midpoint of GS. Might not be completely obvious to see why that is. I guess it's really just because E was created to be the midpoint of GS. So therefore, because it's a midpoint, the two pieces that make up either side of it are congruent. And by angle, side, angle, the triangles are congruent. Now that lets us say JE. JE is a midsegment of a triangle. And the triangle we're talking about is the big one. I'm going to slide back over to this diagram. This big triangle in here, made by extending ME all the way out to this point T. We want to create that. This JE is supposed to be a midsegment of that triangle. And because it's a midsegment of a triangle, this line is half the size of DT. So we're going to use that too. Maybe now, maybe later on. But by corresponding parts of congruent triangles, ME is congruent to TE. That means E is a midpoint of MT. Okay. Using the midsegment of a triangle theorem and the reasoning, prove that JE is parallel to MG and JE is parallel to DS. Well, these two are parallel. That's DS and MG. They're the bases of the trapezoid. And JE is parallel to DT because its alternate interior angles are congruent. Also, JE is parallel to MG because of corresponding angles. So therefore, all of them are actually parallel to each other. And so we've established that the midsegment of a triangle theorem creates a midsegment of a trapezoid that is parallel. Use the midsegment of a triangle theorem and reasoning to prove that JE is half of MG plus DS. Well, it's a triangle, right? MDT is a big triangle, and JE is the midsegment of it. So JE is half of that bottom edge of our large MDT triangle. DT is what you get from adding DS plus ST. I mean, they're right there. It's the two segments on the bottom of that new triangle. However, ST and MG are congruent because in their own small triangles, they're matching parts of their corresponding parts of congruent triangles. So they have to be congruent. That's the CTC. And so therefore, through substitution, putting all of these pieces together, JE, the midsegment, is half of the bases added together of the trapezoid. That is 100% the trapezoid midsegment theorem. The midsegment that connects the legs of a trapezoid is parallel to each of the bases, and its length is 1/2 the sum of the lengths of those bases. We are probably going to practice. No, we move on from here. All right, there's more to follow. Practice will happen on like your Mathia or on the homework, and so I encourage you to keep up your work with those. Thank you for watching this video, and I will see you in the next one. Page 414 is next. Bye.